Callie from Aberdeen Science Centre. Have you heard the news? The space around Earth is getting crowded. In addition to operational satellites, around 900,000 objects made up of old space equipment that no longer works, and things like gloves and toolkits accidentally dropped by astronauts, are still in orbit around the Earth. The Hubble Space Telescope, the International Space Station, and the soon-to-be-launched James Webb Space Telescope help scientists explore space, but all operational satellites are under constant threat from space junk. While many pieces of space debris are less than 1 centimeter, they could still do a lot of damage in a high-speed collision. With the cost of developing and building satellites, their use in essential services such as communication, navigation, and weather monitoring, and their unlimited potential to unlock the mysteries of our solar system and beyond, how do we make sure they have the best chance to withstand impact from space debris? Spacecraft are subjected to a large number of tests during every stage of development, leading right up to their launch. Today, we are going to put a series of materials through a rebound test to determine how these materials might react if impacted by a piece of space debris. To follow along with this activity, you will need a marble or small ball, an empty cereal box or other piece of long, thin cardboard, a stack of books or something similar to prop up one end of your track, a ruler, a wall, a selection of materials such as a piece of cardboard, a sponge, a piece of polystyrene, a piece of wood or something metallic, scissors, tape or blue tack, and a piece of paper and pencil to record your results. To start, I'm going to draw a channel the width of the marble down the center of my cardboard. This will create a track that will help keep our marble in line. Next, I'm going to fold up at each line I've created. And then to allow for a smooth curve, I'll cut notches in the side. Next, we'll find a flat surface next to a wall and line up one end of the track with the wall. We'll use our stack of books to prop up the other end of the track and secure in place with tape, making sure that part of our track is still flat against the table. Place the ruler alongside the flat part of the track so that the smaller number end is against the wall. Hold your marble at the top of the track and release it so it travels down the track and impacts the wall. If your marble rolls off the track, try bending the sides of the track or reducing the number of books and try again. If your marble rolls down the track, towards the wall, and bounces back up the track, your track is ready to use. To make our rebound test as fair as possible, try to choose material samples that are small and similar in size. This will ensure the marble travels the same distance to impact each of the materials. Down one side of your paper, write the names of all of your sample materials and using your ruler, create the other columns and headings on the worksheet as shown. Place one of your sample materials on top of the track, close to but not touching the wall, and hold in place with one hand. Adjust your ruler so the start of the ruler is exactly in line with the edge of your sample material. Hold your marble at the top of your ramp and drop the marble, allowing it to impact the sample material. Be prepared to look closely at the distance the marble travels back up the track because we'll want to record this on our worksheet. Drop the marble towards the material 2 more times and record the rebound distances. Add up all 3 of your measurements and divide that number by 3. This gives you an average rebound distance for that material. Carry out 3 marble drops with each of your remaining materials, making sure that the ruler is exactly in line with the edge of each material and recording your rebound distance after each drop. After all of your drops, find your average rebound distance for each material and number your materials in order of highest to lowest average rebound distance. It's time to have a look at our results and find out what they tell us about a material's ability to protect a spacecraft from impact from orbital debris. Here are our results. The larger the rebound a piece of space debris takes off a spacecraft in the event of a collision, the less damage the spacecraft will suffer. In our test, polystyrene and sponge created the largest rebound of them all. Does that mean these are good materials for making a spacecraft? Not quite so fast. Space junk is not the only threat in space. What other properties of these materials would scientists want to test before determining the best materials for making spacecraft? Other key properties of spacecraft materials include things like strength and stiffness, properties our sponge and polystyrene definitely lack. Spacecraft are built using materials like lightweight metals and Kevlar, and new materials are being developed all the time for use in the space industry. The first step in the fight against space junk is to create spacecraft that can withstand impacts in space, limiting the amount of new space debris created in collisions. Research funded by the UK Space Agency hopes to create something like a traffic management system to keep operational satellites out of harm's way in the future. The website Stuff in Space is an excellent resource to show you the traffic jam of spacecraft and space junk in Earth's orbit in real time. Thank you for joining in this session. Do try this activity at home and let us know how you get on.